Precision measuring tools are required in modern industry. Among these are micrometers, capable of making measurements in 1/1000th of an inch, vernier calipers, capable of measuring large work to close limits, and fixed gauges for production and inspection. In addition to these, there are many precision tools designed primarily for laying out work. An important instrument widely used for layout is the vernier height gauge, which is designed to measure vertical distances from a plane surface. It is an essential tool for making jigs and fixtures and brings a high degree of accuracy to any work for which it is used. The vernier height gauge consists of a vertical blade rigidly fastened to a base. The blade and base are square with each other to a high degree of precision. The scale on the blade is graduated in inches, which are divided into numbered tenths of an inch. The numbered graduations are subdivided into 4 divisions. Each of these small divisions equals 25 1/1000ths. A movable jaw assembly slides up and down on the blade and can be locked in place by small screws. The assembly consists of a gauging jaw and a clamping bar. The two are connected by an adjusting screw. When using the instrument, the jaw assembly is moved to the approximate setting. Then the clamp screw is tightened. Final adjustment is made by the adjusting screw. The gauging jaw contains a vernier scale. The base of the vernier height gauge is ground and lapped on the bottom and also on the top, and its precise thickness dimension enables accurate measurements to be taken from either the top or bottom of the base. The vernier scale on the height gauge enables measurements to be made in steps of 1/1000th of an inch. The scale on the blade is called the main scale to distinguish it from the vernier scale on the movable jaw. The vernier scale on this height gauge is divided into 25 parts. These 25 parts span the same distance as 24 divisions on the main scale. Each vernier division is 24/25ths of each main scale division. Thus, there is a difference of 1/25th between them. A vernier division is 1/25th shorter than a main scale division. Since each main scale division equals 25 thousandths and each vernier division is 24/25ths of this, the difference between the two is 1/1000th of an inch. This is the smallest dimension the instrument can measure accurately. Here we see a reading on the vernier height gauge. 4 inches on the main scale, plus 1 on the tenths graduation, that's 100 thousandths, plus 12 on the vernier scale. The total is 4 inches and 112 thousandths. Observe that in reading the vernier, the final reading in thousandths is taken at that vernier scale index which lines up with any main scale graduation. It is only at 0 setting that more than one vernier index lines up with the main scale graduation. The two at the ends of the vernier scale then line up. Adjacent graduations are very close, and difficulty may be experienced in reading the scales with the unaided eye. A small magnifying glass is an important help to any machinist, especially for taking close readings. A typical use for the vernier height gauge is in laying out accurately such parts as this fixture. The drawing of this fixture shows that 2 holes are called for and that the centers are to be 3.750 above the base, plus or minus 0.003. Even though 0.003 plus or minus is allowed, the height gauge should be set to the exact dimension given. Tolerances allow for minor inaccuracies in the tools used. The casting has been machined on its surfaces and is ready for the layout of the holes. A scribing attachment is fastened securely into place on the height gauge. Remember the dimensions on the blueprint. The center of the holes are to be 3.750 above the base, and the tolerance is plus or minus 0.003. Turn the adjusting screw until the 0 index on the vernier scale coincides with the 7/10ths index on the main scale. That's 700 thousandths. Then continue turning the screw until the 0 index reaches 2 graduations more on the main scale. Properly set, The scales give the desired reading, 3.750. 3 from the main scale inch graduation, 700 thousandths from the 7/10ths main scale graduation, and 50 thousandths from the 2 small main scale divisions of 25 thousandths each, a total of 3 and 750 thousandths. Check the reading to determine whether or not the setting has been disturbed in tightening the lock screw. Be sure that the base is thoroughly clean. Also make sure that the bottom of the work is thoroughly clean and that the plate upon which it rests is also clean. Scribe the line, being sure to maintain a firm contact of the base as it slides along the surface plate. This line is 3.750 inches from the base, just as specified on the drawing. The drawing also shows that the center of one hole is to be 1.250 to the right of the left-hand edge. Turn the work so it rests on this edge. Set the height gauge to 1.250. The reading is 1.250, 1 inch from the inch graduation, plus 200 thousandths from the 10ths graduations, plus 2 divisions of 25 thousandths each, a total of 1 inch and 250 thousandths. The center of the other hole is to be 2 inches from the first one. Set the height gauge 2 inches higher. The zero index on the Vernier scale should be at 3.250 on the main scale. 3 from the inch graduations, 200 thousandths from the 10ths graduations, and 2 of the .025 divisions, 3.250 altogether. The final line is scribed. The height gauge is often used with a test indicator for checking dimensions. Test indicators are of 2 general types. This is an arm-type test indicator. The contact button of the instrument bears against the work. Variations in measurement are shown on a scale, which is graduated in divisions that represent 1/1000th of an inch. Test indicators are instruments that do not by themselves give dimensions of parts. Their function is to show deviations from an established dimension. To determine actual dimensions and precise deviations in measurement, the indicator and the Vernier height gauge are a useful and versatile combination, as in this case, to determine precisely the accuracy of mounting of the 2 studs. A drawing of this fixture shows that the studs are .750 in diameter, plus or minus 1/1000th. The location of the center line through the studs is to be 3.750 plus or minus 3/1000. To check the height of the studs, set the Vernier height gauge to 3.750 plus half of the .750 diameter of the studs, which is .375, thus setting it to 4.125, the established measurement from the base to the top of the studs. Bring the button on the dial indicator into contact with the top of the arm on the height gauge and set the dial pointer to 0. Mounting the dial indicator on a surface gauge facilitates adjustment to a 0 dial setting. This dial is graduated in thousandths of an inch. Transfer the indicator from the height gauge to the studs. The readings on the dial show a deviation from the established dimension of less than 1/1000th of an inch. A deviation of 1/1000th is well within the tolerance allowed on the drawing. Dial indicators have many uses in the machine shop. They are frequently employed to check the centering of work in a lathe. The indicator shows that the work is off-center by several thousandths and that it must be re-centered. Arm-type indicators are frequently used for the same purpose. Test indicators are used to test the straightness of a shaft or to check the mounting of work in a milling machine and for many other purposes. Test indicators and vernier height gauges are precision measuring tools and will operate with precision only if carefully handled in use. Treat them the way fine, expensive tools deserve to be treated. Proper care will maintain their precision and help you in your craftsmanship.